Welcome back to Visual Analytics for Sense Making. This is Module 5, which is the display dimensions for advanced representations. And what we're going to do in this module is deconstruct some of the visualizations and some of the techniques and the visual forms that we've seen in the last modules and start to better understand why different components of those representations or visual forms work in specific ways or are good for specific things, so that we can then take various qualities of those different basic forms and start to create more advanced forms. You had some reading for this module as well, and from that reading I asked you to be able to answer these questions. What are the 4 dimensions of a representation? So what are these display dimensions? And be ready to define each one. What are the pros and cons of the different selections on each dimension? So if each of those are dimensions, you have different selections on each dimension. You know, what are the good points and the bad points of each of those different selections you make? How are the 4 dimensions combined into composites? And what are the classic composites and what are they good at? We'll get started with the first display dimension, which is representation type. There are 3 main representation types, or 3 types of representation. The first one is propositional, the second one is analogical, and the third one is iconic. And we'll describe each of them one by one in the next few slides. The first representation type that we'll talk about is propositional. And this is probably what you're most familiar with. Maybe you didn't think about it as a representation type or that it was propositional, but we are surrounded by these representations all the time. And so these are our words, letters, numbers, and now I want to describe them in a way that maybe you haven't thought about them before. The first is the relationship between the symbol and the reference. So if this is the symbol, this mark and this mark, now you probably know it as a 2 and a 5, but let's consider them as marks in the medium. There's an arbitrary relationship between the symbol and the referent, meaning that there are 2 marks here. That doesn't mean that we have 2 things. We actually have 25 things. So we have to understand the symbology itself and then decode meaning from there. If there happen to be 2 more of these marks, say another 2 and a 5, that wouldn't be twice as much as this. It actually would be 1,000 times as much. So again, the size of it, the shape of it, are not related to the marks in the medium, which is the exact opposite of an analogical, which we'll get to in a second. Again, we're talking about words, we're talking about numerals, and we're talking about things that have great precision. So this is 25, but it could easily be 25.001 or 25.000001. We can get a lot more precision with just adding more characters. And what's important to know about propositional is that it's learned through experience and adopted by convention. So none of us were born understanding that this means any specific thing, and honestly this probably would mean something different even across across cultures or even with neighbors across the street. We use these words or these representations to mean all sorts of things, whether that's state or something like this, or a rate or a difference or a comparison, or just a general relative feeling. This representation can be used for all of those different things. To relate this back to visual analytics work or data analytics work, probably the best example of a propositional analytics display is a data table. So this is a data table for a nuclear plant, some pressures and temperatures that have come out of that over a series of 31 minutes. And so you can see these are all a bunch of numbers. You can see incredible precision. What you'll notice though is that it's maybe difficult to see kind of what the big picture is of what's going on, and that's one of the failings or shortcomings of propositional, especially if I want to show a lot of data at once. The second type of representation is an analogical representation, and now we're basically into the realm of charts and graphs. So in contrast to propositional representation types, now the symbol structure is related to the reference structure. So if you remember before, we had the number 25 up here in this same spot as we now have this grid of 25. And so now I want you to think if I were to duplicate this figure and put it right next to, or maybe it's right over here and it's twice as big, then it would actually represent twice as much. Whereas if I just copy the 25 and put it next to the other 25, it's not twice as much, it's 1,000 times as much. So that the structure of it itself, the height, the length, the number of units, comprising the mark. Now we have 50 units comprising this mark or the symbol. All of those things are actually related to what's going on in what we're trying to describe, or the referent that we're trying to symbolize. Now, an analogical requires a frame of reference or a perspective. It has the ability, as we talked about before with the shortcoming of the propositional, you can't really see it all at once because you have to interrogate and encode each individual datum. With this one, I can observe it all at once. I can see right away with this symbol at the top that I have, it's around, I can count quickly to see that it's 50. I can also see that it looks like it's two groups of 25. It's 10 across by 5 wide, or 10 across by 5 tall. I can see, just quite a bit. I also see that it's red, if that happens to make any difference. So I can start to see that at once. If I were to compare this against what the mark was before, I could quickly see that I'd lost about half of it. Now, it's true that these structures need to be learned. So, say this gauge here, I would have to know what the red region, the yellow region, and the green region would be. I'd also have to figure out what these numbers signify. Let's assume that that's pressure as well, the rate of pressure, or not the rate of pressure, but the state of the pressure at a given point in time. But once I've learned those things, I can quickly bring those up, and I can actually use my visual cortex to help me process this information. I can also see it at a glance. So very quickly I could see, maybe I wouldn't get the exact number, but if I could see that if this mark wasn't sitting out here in the green zone, but instead was sitting over here in the yellow zone, we could quickly at a glance see that something was different, that I was in a different region, and then upon looking at it further, I could probably pick off exactly what the value in the new region was. We also have the ability with the gauge of actually seeing the movement kind of in real time. So we'd see rate changes as well. So if we have something changing rates quickly, we would actually see it moving. You would see that movement quickly across the whole thing. If it was moving slowly, that would give us data about exactly what's going on in the system, not just about the state, but about the rate of change as well. We can also use analogical representations to compare. So, for example, this fellow here is twice as tall as this guy here. If we were to make him even taller, again, you could see the difference, and that height, this distance between here and there would represent the height of this individual. Again, this isn't rocket science, but it's good to think about this, between this and the difference between this and the propositional, where if I said this guy's 5 foot tall and this guy's 2'5", and and I change this to the numbers 10 foot, that's actually not 2 times as tall or 2 times as big. So again, we're connecting the structure of these representations to the referent world itself. So once those structures are learned, we actually use our sensory perception to generate meaning, and then after learning, it requires a lot less cognitive processing than the propositional. And the other thing it does basically for free, or we can put it in very easily, is that context. So with this one, is this data point, or is this value good, bad? We can overlay that context pretty quickly in a categorical way, or potentially even in a continuous way. And the last representation type is an iconic representation. This is kind of in between analogical and propositional. So they do look like the data they represent. They are symbolic in that way. They're simplified. They follow standard conventions that a certain culture or series of cultures can agree upon. For example, this is for a phone, although I can't imagine that anybody reading or listening to this right now uses a phone that looks like this anymore. This is a house, and although it has some structural similarities, we all have roofs, most of us have a chimney, we all have doors. This doesn't look like our house. Now, these are not analogical in that the structure of these, the visual depiction is really just to mimic So getting this to be bigger or getting it to be more phones, or none of the structure of this is tied to the structure. It's really just meant to be a visual shortcut for the word or phrase or number. We tend to use these in situations like this alarm or this alert down below, where we want this to say, we have to say you should be cautious. We can use an icon like this up here to mention, to say that you want to close something. It's good for multilingual settings where we're not sure of the language that the person is going to be when they see this. But we want to proceed with caution because certain icons can be decoded or interpreted differently across cultures. So let me get on my soapbox just for a moment. One common issue we have in this course when we teach it in person is that we tend to not be able to differentiate between infographics or just decorating with icons and actual visual analytics solutions where we're looking for frames of reference. So these tend to be really pretty icons, and they tend to really kind of maybe make our end report or graphic or representation look better, but we have to be very careful that we're not just putting more chart ink on there. We want to really be thinking about what are the data representations and how we're going to use different graphic elements to represent that, not necessarily that this looks like a water drop or this is a fantastic looking widget. That's really just not the purpose of this class. So that being said, I will get off my soapbox and I won't get on that particular one again. To demonstrate some of the differences in how these representations work and how they function and what they're good at, I actually wanted to go and show you a couple representations of some research findings that I had to report out on recently. And I want you to look through both those representations, and hopefully you can see what these two different representations are good at. So I'm going to show you propositional, and then I'm going to show you analogical. As a little bit of background before we show the findings, I want to set the stage for what we're going to be looking at. So if you've watched the previous modules, you've seen this visualization before, and basically the research findings that we need to report out on was, in this case, were the subjective findings, or the self-report findings of different characteristics that the physicians thought this representation had versus this representation. So basically, what they thought these two things were better and worse at. In the next two slides, this is the DAV, or the dynamically annotated visualization, and this is the alert. And the three metrics that we're measuring on are transparency, understandability, and clinical relevance. So here's the first representation. Now this is propositional. I didn't even put it in a table. It's just flat out raw propositional. So what I want you to do is jot down what the important points are, your confidence that those are the important points, like how confident are you, and then when you're done with that, we'll go on to the next one. So just jot them down. What are the important points here, and then we'll go on to the next one. Now I want you to look at this representation. This is a chart, and I want you to again, same thing. What are the important findings of this? How would you describe them in words if you were to tell somebody else about them? Just jot these down as well. So again, both of these representations are describing the same data, and both of them are basically trying to tell the same story, and that is that the DAV, or the dynamically annotated visualization, performed better, was thought to be more understandable, and that's a significant difference. You can see that, so you have to learn that these are error bars, and that this error bar isn't touching this error bar, so that's significantly different. It ranked higher in algorithmic transparency, again, that's significant, and with clinical relevance, also better, and with a significant difference. Now, with the numbers, we had to also it also said that all three were better, but you had to know that p is less than or equal to 0.05. That meant significance. So that was the decoding you had to do from the numbers. With this one, you have to decode it visually, but there's decoding in both areas. So hopefully, you can see that when I have this chart in front of me, you can quickly kind of glimpse on that and understand the main point right away. And I think that's one of the things they try to mean when they're talking about a picture being worth 1,000 words. It's just we can quickly see it and interpret it, and the meaning is a lot more clear, especially with a good visualization in an analogical representation.